Hey, this is Mr. Warden. This is a video key for Algebra Do Now 28.1, and this is going to be focused on prepping you for quadratics 2, which is about multiplying linear equations and seeing what you get. So Jimbo reorganized 41 times 23 into 40 plus 1 times 20 plus 3. That's legit, 40 plus 1 and 20 plus 3. And then he multiplied them, and he got 800 plus 3, or 803. What did he forget to do? Well, here's what he remembered to do. He remembered to do 440 times 20, and he remembered to do 1 times 3, but he forgot to do 40 times 3 and 1 times 20. And so, and that is what he forgot. Okay. Okay, he forgot to completely multiply. He multiplied 40 times 20 and 1 times 3, but he left out 40 times 3, and that's not 40. Let me write that in there. Should be a 40. 40 times 3 and 1 times 20. And so if he did all of that, he would have ended up with 800 plus 120 plus 20 plus 3, which ends up being 943. And that's what he should have gotten. So he left 140 on the table. Now, when you multiply two linear equations, what you get is a quadratic polynomial. If you had said a parabola or a quadratic or just a polynomial, all of those would be fine answers. Specifically, multiplying two linear equations gets us a quadratic. Now, Jimbo went on to multiply x plus 5 times x plus 2, and he worked out that it was x squared plus 10. So what did he forget on this one? Well, once again, what he remembered to do was he remembered to do x times x, and he remembered to do 5 times 2. So the x times x got him an x squared, and the 5 times 2 got him a 10. But he forgot to multiply x times 2 and 5 times x. Because the x times 2 would have gotten him a 2x, and the 5 times x would have gotten him a 5x. So he left 5x and 2x on the table, or should I say 7x. So he should have gotten x squared plus 2x plus 5x plus 10, which we can simplify to x squared plus 7x plus 10. That's what he should have gotten. Now, let's take a look at these equations. We're going to see which ones match. I'm going to copy this, go into Desmos. I'm going to use the note function so I don't lose track of things. And then I'm going to go ahead and just copy pasta each one of these. Actually, I'll do it this way. Okay, got that one. So there's a nice little parabola for you. And then we've got this one. I think it'll be faster if I just do this. Okay. And then he did this one. Now, where is that green one? Oh, so that's samesies. Let's see the x plus 10. The x plus 10 is up there. That's not the same thing as x plus 5 times x plus 2. X plus 5 plus x plus 2 is here. X squared plus 10 is up here. And then when I click on this one, we realize that these two are samesies. Okay, and it should make sense because we just multiplied it out. That x plus 5 times x plus 2 is x squared plus 7x plus 10. Because x times x is x squared. The 5 times 2 is 10. But then the 5x and the 2x add up to make 7x. So x squared plus 10 is a totally different equation. They do both share the same y-intercept, of course, but x squared plus 10 does not share the x-intercepts of x squared plus 7x plus 10 or x plus 5 plus 2. Okay, so let's go back into that do now. Okay, so x plus 5 times x plus 2 and x squared plus 7x plus 10 match. Those are the same equation. Now, where did the 10 come from? Where did the 10 come from in x squared plus 7x plus 10? Well, it came from right here. It is what the 10, let me just put it this, the 10 is what y, or the function, equals when x is 0. Because if x is 0, x squared is 0, and 7 times 0 is 0. So 0 squared plus 7 times 0 plus 10 is going to equal 10. Okay, the 7x comes from, and the other place to think about where the 10 comes from is if x was 0 here, I'd have 0 plus 5 times 0 plus 2. Okay, and so x would be 0, so I'd be left with just 5 times 2. X plus 5 times x plus 2 is just 5 times 2, which equals 10. Okay, the 7x comes from the product, I should say the sum of the products of 5 and x and of 2 and x. Okay, so 5 times x plus 2 times x equals 7x. I hope that was